This video will show you how to calculate and prepare a dilute solution from a more concentrated stock solution in the biology laboratory. Sometimes you have a solution that is more concentrated than the solution that you actually want to use in the laboratory. So how do you go from this solution, let's say this is solution number 1, to this solution, solution number 2? Well, we can see that solution number 2 is lighter than solution number 1, and yet the volume of solutions 1 and 2 are the same. So what's different between solutions 1 and 2? Well, if it's not the volume, then it must be the amount of solute that's present in each of the two solutions. We would infer that since solution 1 is darker, it has more solute than solution 2 does, and that's true. But how could you make solution 2 from solution 1 without instead making two separate solutions? Which you could do. You could add a certain amount of solute to a certain amount of certain volume here, and you could add a certain amount of solute to a certain volume here, and you could make two solutions. But if you already had solution 1, how could you prepare solution 2 from solution 1? You'd accomplish that task by diluting solution 1. One of the easiest ways to figure out how to dilute a solution is to use the dilution equation. The dilution equation is really easy to use. It's set up with two variables, C and V. C is the concentration of the solution, V is the volume of the solution. You can see in this formula that we have C1, a V1, a C2, and a V2. C1 is the concentration of solution 1, V1 is the volume of solution 1, C2 is the concentration of solution 2, V2 is the volume of solution 2. So how do you use this formula to actually calculate what you need to do to dilute solution 1 to prepare solution 2? Let's start with a very simple mathematical manipulation of this equation. Let's say that we had a solution, C1, that had a concentration of 10%. And for right now, 10% just means the amount of solute per amount of solvent. So in other words, you could think about this as you've got 10 grams of solute in 100 milliliters of solution. I'm going to set V1 equal to X for right now, because in reality, I don't know what volume of C1 I'm going to need to use to make solution 2. In fact, I'm going to use this formula to solve for V1 to figure out what volume of solution 1 I'm going to need to use to make solution 2. Let's say that I want solution 2 to be a 5% solution, and that I want to make 100 milliliters of that 5% solution. Well, by using the dilution equation, I can see that 10% times V1, which again, we don't know, we're solving for, equals 5% times 100 mils. Because again, I want to make 100 mils of a 5% solution. Well, if I solve for X, I can see that X will equal 5% times 100 mils over 10%. Well, my percents are going to cancel. 5 times 100 is 500, divided by 10 is 50. So this tells me that V1 equals 50 milliliters. But what does that mean? I wanted to make 100 mils of solution. Well, remember, this is the dilution equation. So what this formula actually allows you to do is figure out how much of solution 1 you would need to use to prepare solution 2. But I'm diluting, so in order to accomplish my task, I'd have to add 50 mils of water to 50 mils of solution 1 to prepare 100 mils of solution 2 at a 5% concentration. So if you think about it, by adding 50 mils of water, I diluted the solution in half. Well, my goal was to go from 10% to 5%, and I have accomplished that goal by diluting the solution in half. In your lab, I'm not going to give you a percent solution. I'm instead going to give you a solution that has measured in units of concentration that are milligrams per milliliter. You're going to have to do some background research to find out to what concentration you're going to dilute this antibiotic solution, but let's try an example calculation so that you're more comfortable using the formula to calculate or to perform your calculations. So we're just going to make up some numbers here. Let's say now that C1 is 10 milligrams per milliliter. Again, I don't know what V1 is. That's what I'm going to solve for. And let's say that I want to make a solution that is, let's see here, let's go to 10 micrograms per milliliter. And I'm only going to make a small volume of this solution. I'm going to make 10 milliliters this time. So I know that V1 is going to equal 10 micrograms per mil times 10 milliliters all over C1, which is 10 mgs per mil. Now, where before we had percentages in our numerator and our denominator, now I have different units. And you can't cancel different units. This is basic 9th grade chemistry. So what that means is that I'm going to have to choose one of these two values and convert it so that both units in the numerator and denominator of my quotient are the same. So how do I do that? Well, I can go in either direction. I could try to calculate how many micrograms are in 10 milligrams, or I could figure out how many milligrams are in 10 micrograms. Doesn't matter how you do it. I'm going to go ahead and figure out how many micrograms are in 10 milligrams. Well, if I have 10 milligrams, I know that every milligram has 1,000 micrograms. This is basic metric conversions, and yes, you should remember this from 9th grade. So I can see here that my milligrams would cancel out, and I'd have 10,000 micrograms. So if I have 10 milligrams, I actually have 10,000 micrograms of solute. So now I can go back to my formula. V1 equals C2, 10 micrograms per mil, and I was going to make 10 milliliters of that solution, divided by, now I know that my 10 mg per mil solution is actually a 10,000 microgram per mil solution. So I can see here that my milliliters would cancel, and if I'm going to divide this value by this value, I'm ultimately going to be multiplying by the reciprocal. So I'm solving for V1, so my micrograms are going to cancel, and I'm going to have 10 times 10 divided by 10,000. Well, 10 times 10 is 100, and 100 divided by 10,000, I can just go ahead and cross out my zeros here. I'm going to be at 1 divided by 100, or 1/100th of a milliliter, which hopefully you can convert into microliters. It's a lot easier to measure microliters than it is to measure a milliliter. 1/100th of a milliliter would be the same as 10 microliters. So I calculated on the previous slide that I would need 10 microliters of my 10 mg per mil solution to make 10 milliliters of a 10 microgram per milliliter solution. So what does that mean when I actually go to make the solution? Well, I'm not dealing with a very large volume of solution, but luckily there are tools that we can use to measure 10 microliters. So if my final volume is 10 milliliters, just like before when we had 5 mils of concentrated solution and we add 5 mils of water to it to make up a final volume of 10 mils of solution, in this case our final volume still needs to equal 10 milliliters. So I can't add 10 microliters of solution to 10 mils of water to dilute this solution. But ultimately, since I'm dealing with such a small volume, I'm going to do something that's very, very similar to that. So 10 microliters is really just a fraction of a milliliter. It's 1/100th of a milliliter. Well, since 10 mils is the same as 10,000 microliters, if I need to add a certain volume of water to my 10 microliters of solution, if I subtract 10, in this case, I can figure out that I need 9,000 990 microliters of water and 10 microliters of my 10 mg per mil stock to make a final volume of 10,000 microliters or 10 mils of solution. So to make this solution, I would add 10 microliters of my 10 mg per mil stock to 9,990 microliters of water to make my final 10 mils of 10 microgram per milliliter solution for this laboratory.